cell membrane and the cell wall, more acidic here. So you can see how it matches. Pretty amazing. And this thing here is just an indication of something called a proton pump. And what happens is that the cell wants to send the protons out, so that there's a difference between, it's almost like the difference between a charge between the outside and the inside, called a proton gradient. Exactly what's happening here as well. As the fluid comes out, it'll wash out any extra hydrogen, well, protons, and we'll have a difference in the gradient here. So there's a proton gradient here, a proton gradient here. And the other part of this, which is interesting, is this is a very small cell. It's just like in the bonds that we saw before. Atoms or molecules can come in, stick to the side, which is made of minerals that are excellent for catalyzing reactions. Join up together and get concentrated and probably, hopefully, form larger molecules. And so you can see why this is thought to be a really good precursor for the cell, and maybe not necessarily instead of the warm pond. I'd like to think it'd be both options, would be quite neat, but it seems that that may be the way for life to get started. And hence that's a candidate for the precursor to the prokaryotic cells. So far, we've found our building blocks are really easy to make throughout space. We've seen a couple of ways life might be able to get started, and we've seen some examples of extreme life. So now we actually want to find somewhere for life to start, and not only to start, but to be able to carry on living and functioning. We had on Earth, but let's see what else we might have. And that brings us to habitable zones. So the traditional habitable zone is this area here, where the region where liquid water can exist on the surface of a planet or a moon, because it's just the right temperature. But of course, the planet or moon will need an atmosphere to keep the water as a liquid form. As you lose your atmosphere, like Mars, it's lost a lot of its atmosphere, but not all of it. You lose the atmosphere, and the boiling point will drop, so that eventually water will not exist as a liquid, it will just turn from ice straight to gas and be lost. So that's why we do need an atmosphere as well. And so Earth has been lucky that way. Mars used to have an atmosphere, got more of an atmosphere than it's got now. Remind me that there's a little bit of an atmosphere. And so that's the traditional habitable zone, where we used to always think, well, astronomers used to always think we should look for life. But there's another one out here, out by Saturn. This is the liquid methane habitable zone. And in this area, we've just been from Saturn out a little bit. It's just the right temperature where methane could exist as a liquid on the surface of a planet or a moon if it had the right atmospheric pressure. So that's given us now a second habitable zone. And there's another one as well, and this is the tidal heating habitable zone. So around a gas giant, there's usually one or two moons which are within a distance where the orbit of the moon will be a little bit uncircular, called eccentric or elliptical, and that means a change in distance from the planets as it orbits, and that causes a bit of squeezing and squashing, which warms up the interior of the moon. Now, we're going to have a bit more of a look at that in a moment, a bit more detail, but that's an extra habitable zone. So now we've got quite a few different places in solar systems, not just ours, but all around the galaxy and the universe where life could exist. So armed with all that knowledge, let's have a look at, I see my cell is not twisting around like it did, but that's, so you can get these little 3D models from NASA, and actually you can get these actually move around. This one is Enceladus, a tiny moon of Saturn, one of Saturn's 82 moons. Not 82 moons, there's probably more to be discovered. So if you look out into the sky at night at the right time of year, you'll see Saturn in the sky. Its closest approach to Earth, about 1.2 billion kilometres, and that's just over an hour of light travel time. depending on where Earth and Saturn are in their orbits. So this is where we're going first. We're going to have a look at Saturn, out at Enceladus, out of Saturn. So here's Enceladus, only about 500 kilometres across, a very small icy moon. And you can see next to Earth and our moon just how small it is, this tiny little moon. And this picture is the day the Earth smiled, taken back in 2013, I think it was, by Cassini. It's a mosaic of a lot of pictures put together, with the sun behind it and shining through the rings, giving quite an amazing effect. You can see some of these rings that you wouldn't otherwise